Hi again, this is Tim Hegarty. We're taking a look at the Virtual Training Company C++ fundamentals, and now we're going to do enums. Well, enums are really called enumeration types, and it is a special user-defined type rather than a built-in type, and it is going to hold a set of values specified by us, the user. Now, an enum acts like an integer after you define it, but it is still user-defined. The values that it starts with begin with 0, just like an array index or anything else. We start with 0. So there, for an example, we have enum of sample, that's the tag, and that's the name of the enumerator, sample, and it has values 0, 1, 2, and 3. And that will be their numeric values when we use them in code. It's much better to do this than to have magic numbers floating around inside your code. So here we have 0, 1, 2, and 3. That can be apple, oranges, bricks, whatever we have in there, and we can even change the number as part of the series. So let me show you how this works. So as you see there, 0, 1, 2, and 3, that would be accurate. 0 would be equal to 0, 1 is 1, and so on. So let's flip over to some code here, and this is in our Visual C++ 2005 Express Edition, a nice little freebie from Microsoft that we showed you how to download and install. And here we have a little bit of code. Here's our enum, and we're just going to call it sample enum. And it has 0, 1, 2, 3. And notice that we changed the value. We said 9 equals 9. Now the next one, if we did another one in here and said 10, just to be consistent, we would not have to put a value because we've changed where the indexing is running. So where this was 0 and 1 and 2 and 3, we changed the value to 9, and now this one would be equal to 10. See that? How it popped up, 10 equals 10. It already knows what that's supposed to be because it knows that we changed the numbering here. So the compiler is already keeping up with us. And here's just a little declaration for our function that we're going to use. And here's our test rig in main, and we're going to call test enum. And since we set it up requiring a sample enum as the input, we have to cast this. So here we cast 0, 1, 2. We can't just pass integers into here. The compiler will complain about it. We'll have a little return value. We just set to 99 to get it initialized, and then we're going to switch on in, and if it's 0, case is 0, then we'll write line 0 out to the console, and we'll return 0. Now I could have just as easily put right here 0, just like that, and then return value equals 1, 2, and here this one is 9, and so on as we go. So let's run this and see what the output looks like. We'll do Control F5, which will compile it, link it, and run it. And there's 0, 1, 2, 9, just what we expect it to do, because we tested 0, 1, 2, and 9. So here our 0 worked just in the same place as the number 0. See how cryptic that is? Return value equals 1. Well, why? You know, that should be true or false or good or bad or whatever we want to have in there, not just a magic number like that. So that's enumeration, or enum, and that's what we wanted to cover in here. We're going to go on to the expression statement next, so hang in there. See you back here in a minute. Hi again, this is Tim Hegarty, C++ Fundamentals from VTC. We are going to be looking at labeled statements right now, and actually we're going to start taking a look at a lot of different statements, expression statements and selection statements and iteration statements and all kinds of interesting things like that. But let's start out with labeled statements. To be used as the target of a goto, which you really shouldn't do all that much, but if you have to, you have to. But for a statement to be used as the target of a goto, it has to have a label, it has to have a name, so that the goto has someplace to go to. There are 3 types of labeled statements. The first one, which we're used to for goto, is identifier :statement. That's the label, and then whatever the label refers to, that one's used by goto. The next 2, though, the case, constant, and then statement, that's used in a switch case, we're familiar with that, and the default : statement is also used by switch case, and we're familiar with that. It's exactly the same in C++ as it was in C, but let's take a little bit closer look at it in some code here. So here we have our little bit of a program from before from enumeration, and we're just going to continue on with that, and I've added a few things to it. Here we have our sample enum, and it has 0, 1, 2, 3. Well, now, we had the 9 and 10 in there. That's pretty much the same, but now I've changed this up a little bit. We are going to do a right line of, and I'll make that quit flicking around there. We'll use the right line of our test enum call and passing in 0, 1, and 2. 7 is not in our enum, so we should have some different kind of behavior with it. And 11 is completely out of bounds because the 10 was the top of our enum, the highest enumerator that we could have. So let's see what happens when we make these calls. Down here in test enum, I set up my return value to all 9s just to get some high value out of it. And now we'll do a little test here. If the in value that's coming in is greater than 10, and that's our enum, if it's greater than 10, then we go to quick end. Now quick end, that is a label down here. That's our go-to label, and that's what we're talking about, a labeled statement. So here's quick end, and it's going to do a return of retval, whatever's in that little integer, the return value. So you can see our go-to quick end, and that's the one kind of labeled statement. We've already been using the other labeled statements. So here's case 0 and a colon, so that's a label, and we will write line 0, and then we'll return 0 and case 1 and so on down through the list. And then here's our default. That's our third kind of labeled statement, default colon, and that labels what to do if none of the rest of these work. And we'll write none of the above. We'll set our return value to 9s and get out. So we can take a look at what happens here with our different possibilities as we run through our test rig. We'll control F5 and run this. So 0 worked correctly and returned 0. When 1 went in, it returned 1. That's fine. When 2 went in, it returned 2. That's good. Well, now 7, when it went in, we got a none of the above, and the return value was set to 999. So that's our default case. That default worked and said none of the above, returned 999. Then when 9 went in, it returned 9 properly, the way it was supposed to. And then here, this 999 is from our when we put 11 in, and 11 went in, the if statement caught it. I remember that the if statement caught it because it was greater than 10, and we went right to a quick end, which the return value was already 999. We jumped down to quick end, and we were out of there. So that did exactly what we thought it would do. And we are looking at labeled statements again. So we want to see the labels. There's the use of a label in a go-to. There's the definition of labels. 0, 1, 2, that's the case, and a constant and a colon. We're just using the words because we have our cool enum up there, enumerator. And then down here we have our quick end actual label, which jumps us out. And that's labeled statements. Hi, this is Tim Hegarty, VTC C++ Fundamentals. We're going to talk about expression statements. And we really don't have to talk about it very long, but it is quite important. An expression statement is a statement in the language that performs work without transferring control or any kind of iteration, like a loop, anything like that. A program is simply a sequence of expressions separated by semicolons, one after the other. Usually, you know expressions as assignments and function calls. They're the most common expressions. And a semicolon all by itself is a null expression statement. Now you're probably thinking, well, I would never use something like that. Now you probably have. If you use a for loop with 2 semicolons in it, that's a forever. It just sits there and runs. Or if you use you could use a while true or something like that to do a forever as well. But a for with 2 semicolons or 2 null expressions in it is a forever loop. And here, for example, a equals b plus c, that's an expression statement. Very simple. Let's take a look again at our sample code and look at some of the expression statements. There's one right there. Int return value equals 999. That does its job. It creates return value, defines it, and then initializes it to 999. But that has to happen before we step down into the next statement and the next and so on. So we can see that we have a number of expression statements. There's one, there's another one. They're doing their thing, and they're the bread and butter of the program. Okay, all separated by semicolons. So that's very simple, but quite important. Important as bricks to a builder is the expression statement. Hi, Tim Hegarty, VTC, C++ Fundamentals. We're going through statements here, and now we want to look at compound statements. We usually know them as a block of expressions, but it's officially known as a compound statement. And a compound statement is zero or more individual statements or expressions, we could easily say, within braces. Those are not squiggly brackets or anything like that. They are called braces. So, for example, if value is greater than 10, then we have an open brace, we do a whole bunch of code, and then a closed brace. Everything that's inside those braces, this bunch of code part, is a compound statement, and the execution of that compound statement is controlled by the if. As you know, an if can run just a single line. You have the single expression with a semicolon, and it would control that one expression, or you can have it control numerous expressions by wrapping them in braces. That's called a compound statement. If we look at this in our previous program, the main program itself is in fact a compound statement because it is enclosed with braces. Starts and ends the function definition of main. And test enum down here has an opening brace. Sometimes conventional to put that brace out here at the end of the function definition. And then we have the other one down there at the end. That's the ending brace for that whole compound statement. And then the switch, though it's a little different construct, it also contains these braces, but that's a different animal. So don't mix that up with what we're talking about in compound statements, okay? So there's an example of multiple items being controlled by braces. And those are compound statements. Hi again, Tim Hegarty, Virtual Training Company, C++ Fundamentals. Now we're going to look at the selection statements. There's only two of them. The if-else and switch are selection statements, and you're probably familiar with them, but we'll just cover them quickly here. If an expression evaluates to true, then we do statement 1. If the expression evaluates to false, got as a 0 value, and there's an else present, then we'll go down and do the else and do statement 2. The else, as you can see by the brackets around it, is optional. You can have the if and statement 1 and move on. The switch switches on an expression and then decides what to do based on a number of cases within the switch, and we switch on a case, constant expression, and then do the statement on the other side of the colon. This links back to our other label expressions and things like that we talked about just a few minutes ago. Let's again take a quick look at our code just to match this up. And here you see one of our selection statements is the if. If the n value is greater than 10, then we make a selection. We select which code to perform. That's what's happening here. We select the path of execution. And in this case, the if would say go to quick end, and we know that we're out of the program. Here we switch on in and then decide in case, that's the way I always read it, in case it's a 0, in case it's a 1, in case it's a 2, do these things that are between the colon and the break. You probably know, but it's worth repeating. If the break is missing, this will just fall through, because remember, these are just labels. And when you if you ever look at the assembler down inside this, you'll see that these are just jump points, and the compiler creates a table, but that's not for our fundamentals class that we're trying to do here. So the switch would cause us to jump to this location, and we would do the console write line and set our return value, and then the break gets us out of the switch. If the break wasn't there, we would fall through and do the next line and so on until we either hit the break or we hit the bottom of the switch and jumped out. So that's a selection statement, if and switch. We have both of them right together. How convenient. And that's the end of selection statements. Very simple, but it is a good solid C++ fundamental. Hi, Tim Hegarty again, Virtual Training Company, C++ Fundamentals. We're going to take a short look at the iteration statements. That's the official term for them. We know them as the for while and do while. They're exactly the same as they were in C, so I'm not even going to write you any code or anything for them. By this time, you ought to know what they are. They are looping constructs. They control how many times a compound statement or a block, as we saw earlier, of compound statements, how many times that is executed. There are 3 sections to it: initialization, evaluation, and increment. There's 3 sections like that to every iteration statement. So the statement, the for loop, does have a space for initialization in it. It evaluates at the top of the loop before entry into the statement block, and it does have a place for an increment as well. The while loop does not have its own initialization, so you have to do it, you have to get everything set for the while to start. The evaluation is again at the top. It's an entry controlled loop, so you can't get into the block of the while unless you meet the criteria. Kind of a doorman at the gate. The increment is also hand done. You have to do your own incrementing. There's no place in the loop for the increment to occur. The do while statement does not have its own initialization. You have to do it. It's evaluated at the bottom. This do while is an exit controlled loop, and it does not have its own increment. You have to take care of incrementing or changing something so that you can eventually get out of the loop. The do while will let you in the building but not out until you meet the criteria. So if we take a look at them here, the while is very simple. Then there's an expression in it, and then a statement. Remember that the statement can be a block of statements surrounded by braces. So we have to get everything set up, initialized, and then we do a test in while expression. We do a test in that expression. If that test to be true, then we go on in and perform the statement afterward. Now, if you happen to have an object or something, a class as that, or a class object as that expression, you have to have a method in there that will evaluate to a true or false, so that it will come out to be a 0 or non-zero value. It's just something to keep in mind. The for loop, it has 3 different sections to it. It has an initialization expression at the beginning, then a semicolon, then the conditional expression, another semicolon, and then the looping expression, which is the increment or something that's changing. Then you have the actual statements that are controlled by the for. And again, that single word statement, that could also be a block of statements there. But the for loop is nice where it gets everything in one place for you. Initialization, conditionals, and looping statements. The do, you have a do and then the block, or a single statement that's going to occur while something is true. So in a do loop, you will always do the block of statements at least once. So you have to make sure that everything is initialized and you're all ready to go. You'll come in and do those statements, and then you'll see, should we do them again with the while at the bottom. And if you should, you'll go back to the do and do all the statements again, and then hit the while, should we do them again, and so on. And notice that there is a semicolon after that close paren on the while of a do while. There is not one, of course, on the while or the definition of the for when we start the control structure of the for. So that's iteration statements, and again, they're just a fundamental. They're the same as they were in C, and break and continue and those things also function in these as well. And we've seen those statements in other parts of this tutorial and in the C programming. But iteration statements. Hello again, this is Tim Hegarty with the Virtual Training Company C++ Fundamentals videos. We're working through statements here, and now we're going to talk about the jump statements. The jump statements perform immediate local transfer of control. So they go from one spot in the program to another immediately. They don't allow a loop to continue or things like that. There are 4 of them: break, continue, return, and go to. So let's take a look at each of them in turn. These are, again, basic fundamentals, so we won't spend a whole lot of time on them and look at a bunch of code in that, but I just want to make sure you're aware of them. The break jump statement, if it's found within a loop, it causes the loop, like a for or a while or a do while, causes the loop to end, and the next statement outside the loop will be executed. The control will transfer to that next statement. We also know that in a break, that the break will cause processing to leave a switch. So if we have a break inside a switch after a case, the break will allow us to get out of the switch. A continue causes the loop to jump to its evaluation statement. So in a while, that's at the top. In a do while, it skips over any other statements and goes to the bottom, does the evaluation to see if we have a true or false, and determines whether to go on through with the loop. A continue that's in a for loop will cause us to go to the increment or the modification section. That's that third part of a for loop. Then we go to the evaluation and decide whether to continue on with the loop or not. A return removes us from a function, backs us out of a function after we've called into it. If a return is in main, then control returns back to the operating system, and that ends the program. And then a goto, we've seen that with our labeled expressions. A goto jumps immediately to the labeled expression and jumps over any other code that is going on, and if it's from inside a loop to outside a loop, then all of the looping construction is torn down and we continue on wherever the labeled expression was. Break, continue, return, and goto are the jump statements. This is Tim Hegarty with the VTC C++ Fundamentals. Our next statement that we want to take a look at is the declaration statement. Now you use this quite a bit and probably don't even really think about it, but the declaration statements are the ones that introduce new names into the current scope, whether you're creating static objects or automatic objects. This is how you make new things. Declaration statements are usually type names, class, struct, union, enum, typedef, and so on, or creating a pointer to something else. They can also be object names when you're creating a new class, and they can be function names when you're declaring a new function. And then of course later on you define the function by putting the statement block underneath it, but you have to declare the function first so that the compiler knows what it looks like and how to use it. So the declaration statement will make automatics and statics, and if a declaration statement is used later on in the code, not up at the top, which is a new thing for C++, you couldn't do that in C. If you do declarations deeper into your code, then the new automatic hides the previously named item that might be of the same name. So if you're creating or declaring a new item into your current scope and it has the same name as a previous item, the old one will be hidden. That's basically what we're trying to say. When you then leave the current scope, the new item that you created, the new object created with the declaration statement, will be destroyed. If it was a class, its destructor will be called, or if it's just an automatic, its memory will be recovered out of the heap. So that's our declaration statement. Allows us to make new names, new objects in the current scope. This is Tim Hegarty with the VTC C++ Fundamentals. Here's our last statement that we're going to be taking a look at in this section, and this is the try, catch, and throw statements. They work together to implement exception handling. We will be looking at this in more detail towards the end of this C++ Fundamentals video series, but I just wanted to show them to you right now just to give you an idea that they exist, and that kind of wraps up our statements section. Try and catch will set up guarded code, is what it's called, and also signal what to do if there is an error, an exception is raised within the code that's in the try block. The throw is used within the try block to actually raise the exception, to say yes, in fact we are having a problem here, so that catch can do something about it. So let's take a look at a sample piece of code here. Here's our little bit of a main function here. We can create a character buffer, and here's our guarded code inside of our try block between these braces. So our try block says that buff equals a new character of 512 bytes. If the buff equals 0, that means that this new failed. The initialization of this thing failed, so we couldn't get the memory. We will throw a memory allocation failure. We'll throw a piece of text, and you can throw about anything. You can throw a class, you can throw an integer, you can throw a string. It doesn't really matter. Now look here, this is the catch block. The catch block is right underneath the try block. They go hand in hand, and there can be multiple catch blocks to be able to catch multiple different kinds of exceptions out of here. In our case though, we just want one catch block. That's all we need. We'll catch the character string that comes in at us, and then we'll just do a simple out. Exception has been raised, and we'll put the string. So this would produce, if it could not get to memory, this would produce to the console exception raised memory allocation failure. Alright, that's a try, catch, and throw statement. All three of them used together. Now there's a lot of other stuff about function unwinding and things like that about how this is able to do this, and like I said, we will see that at the end of this, towards the end of this video series. So hang in there with me, and we'll move right along after the try, catch, and throw statement. Hi, this is Tim Hegarty with VTC, C++ Fundamentals. Let's take a minute to talk about inline functions. Now, we already saw inline functions way back in chapter 1 or 2 when we were looking at creating classes and methods within the classes, and some of the methods like the constructor methods of the class were set up inline because they were very simple, usually one, maybe two lines of code, very basic, nothing fancy, and you could put that code inline. We can do the same thing with a function. When you declare and then define a function, you can define it as inline, and that will tell the compiler that if at all possible, put the code of this function directly in the place of the function call. So instead of, when you get to the function call in main or wherever you are, instead of pushing things on the stack and transferring control, jumping over to the function, and then you perform the function and then you do a return back out of it, what will happen is the actual code of the function will be placed in line. So it's not always possible, though. Depends on how complex of a function you create and how smart your compiler is, whether it can create that code inline. Here's an example of what it looks like, though. There's an inline int func inc, which is just an incremental little function. This is kind of worthless, but it would do it. And it takes in an integer I. And what it's going to do is return I++, I incremented, back out of func inc. But by causing it to be inline, the ++ will be right in line with the calling code. So we will not jump over to another function and then have to return for something so simple. It's usually, or it has to be really, a very simple code, very basic to make it inline. It's strictly there to create faster code, to try to shave a few cycles off of the whole execution time. But again, you use it wisely, and if you abuse it, the compiler will just ignore you and it'll make a normal function, just so you know. So that's inline functions. This is Tim Hegarty with the VTC C++ Fundamentals video training course, and now we're talking about namespaces. Namespaces are used to kind of subdivide the world. They allow us to subdivide the global scope into subscopes. You can kind of think of it as having a 1, 2, 3 Main Street. That's all well and good, but if you don't know what city and state you're in with a subdivision of your global scope, then you don't know what you're referring to with 1, 2, 3 Main Street. Well, that could be the same thing with X and Y and some kind of character and whatever other kind of variables we might have out there. So C++, this is a brand new thing for C++. C did not have this. C++ adds this concept of namespaces, and you use the word namespace and you give it a name, and then your definition of all of your code and classes and all kinds of functions and things that make up the namespace will be inside the braces in the definition part after the name. You then use the word using to select the namespace or multiple namespaces that you want to use in the particular part of code that you happen to be in at the time. And we'll take a look at an example here in just a minute. You can also make a new name for an old namespace. The old namespace might be really long and drawn out, so you can give it a shorter name, make it a little easier to write your code then later on. Let's take a look here quickly at an example. Here we're using a namespace called system, and you can see that our compiler here, our Visual C++, gives us some information about what the system namespace has in it, beyond anything we're going to talk about here, but it's there for your information. Now here we've created a namespace and called it first, all right, because it's the first one. And again, the compiler's helping us out there by showing us the name. And we have an integer x and y, and they're equal to 100 and 101. And then we have a new namespace called second. Pretty original. And that has an integer x of 200 and a y of 201. Now down here in our program, we can say that we want to use namespace first. And if we do that, when we say that, now when we do a write line of x or y, notice the compiler understands that it wants integer first x because we said to use this namespace first. Notice that our scope changed up here to global scope when we click down inside main. If you click on second here, our scope changes to second because this is a list of all the different subscopes that we have. We have global and first and second, so we have created different scopes. So here I've given you a little comment that this is the first scope. This one will also be first scope. But now we can still get to the second scope and the things that are in it, the second namespace, by calling it out with this operator, the double colon scope operator. We say second colon colon x, and then you can see that the compiler also understands we are talking about the x that is in the second namespace, not the first. Now here, if we do a right line of y, since we're not calling out the second namespace, it's going to revert back to the first, because that comes from this using namespace up here. Now we can specifically say that we want to use the second y anytime there's a reference to y. So when we come down here and we look at x in this right line, it's going to use first because this namespace declaration is still up here. So that x is still hooked to that first, but y is going to come from second y. And that's because of this using right here. So you can see that we can use namespaces in a couple of different ways, and I didn't put the rename of a namespace in there just because it's so simple. And it's pretty straightforward to run. And we get first, second, first, second. Okay, first, second, first, second, which is first, second, first, second, just what we expected to happen. And that's the concept of namespaces, which lets you subdivide the world, subdivide your global scope into subscopes. Very, very useful. You'll see it used quite a bit, especially if you're maintaining older, large blocks of code and looking around inside the system code that Microsoft gives you, or any of the compilers. If you like a good a GNU or a Linux compiler, or CPP, take a look around inside their system code. You'll see a lot of use of namespaces to kind of organize the world. This is Tim Hegarty again with the VTC Virtual Training Company video training course on C++ fundamentals. Here's a quickie for us, typedef. These are typedef types, and we've kind of just tucked this here on the tail end of this section because it's kind of goes along with it, but you already know about it from C, nothing new for C++. Typedef simply causes one type to be known by a different name. Typedef does not add any new types. It just makes things a little easier for us to read. For example, there's a typedef of a char star, a character pointer called pchar, or pointer to character. There we've typedefed an unsigned long as a ulong. There's a typedef of a character called field, and it'll be an array of 50 bytes. Then we can use those by saying like pchar new pointer, so that will create a new char star, and field member name would create maybe in a database piece of code that we're working on that creates a member name as a character of length 50. So very simple. Actually is just there so that it makes things more readable for us, increases readability, a little simpler to work with in your code, and hopefully reduces some errors and some confusion when you're looking at the code at 2 o'clock in the morning a year after you wrote it. So typedef.